Hey there and welcome to AI Lab 99. Today we'll be building our next application, the Auto Insurance Premium Estimator. We have a dataset containing the age of a person and their accident history, and our goal is to predict auto insurance premiums based on these inputs. We'll develop a machine learning model and deploy it as a web application that allows users to quickly estimate their premium. Let's begin. Let's launch the Jupyter Notebook, creating a new notebook. We'll begin by importing pandas. Next, let's load our dataset into a data frame using readCSV function. And to quickly take a look at the first few rows, we'll use df.head. In this dataset, we have three columns. The first one is the age, which is a numeric feature. The second is caused an accident in past 2 years. Looks like it only takes two values, yes or no. That makes it a categorical feature rather than a numeric one. Finally, we have annual premium in USD, which is our target variable. So our goal is to use the first two columns as inputs and build a model that predicts the annual premium. Let's run df.describe to take a look at the stats. In our dataset, we have 1000 records. Looking at the summary statistics, the average age is about 41 years, with the values ranging from 18 up to nearly 65. For the annual premium, the average is around $1,800. Most customers fall between 1550 at the lower end and just over 2000 at the higher end. The smallest premium is about 1284 while the maximum reaches up to 2384. You'll notice that the caused an accident in past 2 years column doesn't appear here. That's because it isn't numeric. It is a categorical feature with values like yes or no, and we'll need to handle it differently during pre-processing. Let's see how many people in our dataset have caused an accident in the past 2 years. We'll run value counts on this column. We can see that 570 entries are no and 430 entries are yes. That's a fairly balanced distribution, which is good for training. Since this column contains text values and machine learning models can only work with numbers, we'll need to convert these categories into numeric form later during pre-processing. Now let's explore the data visually to understand the relationships better. I'll start by plotting age against annual premium in a scatter plot. Age goes on x-axis and annual premium goes on y-axis. Here we can see a clear downward trend. As age increases, the premium tends to decrease. But notice something important. The points are not spread in a single band. They're split into two distinct groups. This tells us that the age alone is not enough to predict the premium. If we try to draw just one line through this data, it wouldn't capture both the groups well, right? So what could be causing this separation? Let's check the accident history column. I'll make a similar scatter plot with accident history on x-axis and annual premium on the y-axis. And here it becomes much clearer, right? Customers who have not caused an accident are clustered to a lower premium range, while those who have caused an accident are shifted into a higher premium range. This perfectly explains the two bands that we noticed in the age plot. To confirm this, let's combine age and accident history into a single visualization. I'm going to split the dataset into two groups. One data frame will contain only the rows where caused an accident history in past 2 years is yes, and the other will contain the rows where it is no. Now I'll create two different scatter plots for both the groups separately and specify the labels clearly. Adding the legend for the same. Okay, so from this chart, we can see that both groups follow the same downward trend with age, but they're clearly separated into two clusters depending on the accident history. This confirms that to build an accurate prediction model, we need to use both age and accident history together as features. The next step is to convert the accident history column into numeric form so our machine learning model can understand it. I'll modify the column to have numeric values by mapping yes to 1 and no to 0. Running df.head again to see the change. We can see the transformation. Instead of text values, the column now contains zeros and ones. Now that all of our features are numeric, let's prepare the dataset for model training. First, I'll define X for our input features, that is age and accident history, and Y will be our target variable, which has the annual premium column. Now we'll split the data into training and test sets using train test split from Scikit-Learn. I'll use 80% of the data for training and 20% for testing. So the test size will be set to 0.2. I'm also specifying a random state. This makes sure that every time we run this cell, we get the same split between training and test data. This keeps our results consistent. When we check the shapes, we can see that there are 800 rows in the training set and 200 rows in the test set, which reflects what we have mentioned in the train test split. Now let's import a simple model, linear regression. We'll fit the model on the training data to learn the relationship between our input features and the premium. All right, the model has now been trained. To test it quickly, let's make a sample prediction. I want to predict the premium for a 20-year-old who has not caused an accident. So I'll give 20 and 0 as inputs. 0 because we mapped 0 to no accident history. And the model estimates the annual premium at around $1,799. So what's happened when we call model.predict? Behind the scenes, our linear regression model is using a very simple equation, y equals w1x1 plus w2x2 plus b. Here, y is the predicted premium, x1 is the person's age, and x2 is the accident history. W1 and W2 are the weights or coefficients the model has learned for each feature, and B is the bias term. When we trained the model using model.fit, what it actually did was learn the values of W1, W2, and B. Whenever we call model.predict and give it some inputs, those inputs are plugged into this equation. Here, the model substitutes the value of age and accident history of 20 and 0 into the formula, multiplies them by the learned weights, adds the bias term, and gives the prediction of $1,799. Now let's actually take a look at the values the model has learned. I'll print out the coefficients and the intercept. Here, the coefficients correspond to the weights W1 and W2 in our equation, one for age and one for accident history. And the intercept is the bias term, B. Now that we know the weights and bias, we can actually write our own predict function to verify what's happening behind the scenes. Here, I'm defining a simple function that takes in age and accident history, and then apply the same formula the model has learned. It's going to be the bias plus age multiplied by its weight plus the accident history multiplied by its weight. When I call this function with the same input, a 20-year-old with no accident history, we get the exact same result, about $1,799. This confirms that under the hood, our linear regression model is just plugging the inputs into this learned equation to calculate the premium. Now let's talk about how to interpret this model. Our linear regression equation looks like this. Hypothetically, if both input features are 0, meaning age is 0 and accident history is 0, the prediction would simply be the bias term, which in our case is about 1998. That's why we call it the base price. It represents the starting premium before adding the effects of age or accident history. From there, if we look at the age coefficient, we see that it has a negative sign. This means that as age increases, the premium decreases. Specifically, for every 1 year increase in age, the premium goes down by about $10. Similarly, if we look at the accident history coefficient, it's a positive value. That means if a person has caused an accident, the model increases their premium by about $500 compared to someone with no accidents. These insights aren't just numbers, they tell us how the model is making its decisions. By interpreting the model this way, we can clearly explain to customers, stakeholders, or regulators why the model is making certain predictions. It makes the system more transparent, showing exactly how age and accident history influence the premium instead of treating it like a black box. Now that we have interpreted the model and understand how age and accident history affect the premium, the next step is to see how well our model is actually performing. I'll use the root mean squared error or RMSE as a metric. RMSE gives us an idea of how far our predictions are from the actual premium values on an average. Importing mean squared error from Scikit-Learn, calculating the RMSE for the trained data, and then the same for test data. Notice that I've added a power of 0.5 here because RMSE is simply the square root of the value returned by the mean squared error function. Here we are seeing that the training RMSE is about 48 and test RMSE is about 50. Since the train and test errors are very close, this suggests that the model is performing consistently and it is not overfitting. And given that our premium values range from about $1,200 to $2,400, an error of around $50 is quite reasonable. With that, we conclude the model building part. Now let's create an interactive web app. I just created a new Python file here. We'll use the Streamlit package to build the web app. Importing Streamlit, adding a title for the app so that it appears at the top of the page, add a short description using Markdown to explain what the app does. I'm creating a number input box where users can enter their age. I've restricted the input between 18 and 100 and set the step size to 1 so users can increment or decrement by 1 year. Next, I'm adding a drop-down select box that asks whether the driver has had an accident in the past 2 years. The options are simply yes or no. Since our model expects numeric input, we'll convert this choice into a number, assigning 1 if the answer is yes, otherwise 0. Adding a button labeled Predict Premium. When the user clicks on this button, we'll run the model and display the predicted premium on the screen. So I'm pasting the custom predict function that we wrote earlier into the app, calling the function when the button is clicked. Finally, we display the result nicely on the screen so the users see their estimated annual premium. Let's run this file, running the command streamlit run app.py. And here is the web page with the title, description, and the input fields. Let's test this with some values. I'll give 18 and yes. And we see the app instantly displays the result. And each time I update the values and click on Predict Premium, the model instantly calculates a new estimate and displays it on the screen. With this project, we have successfully built and deployed our third end-to-end machine learning application. You can find all the code and the dataset in the GitHub repository link below. This was AI Lab 99. Thanks for watching, and until next time, happy coding.